he has really vast amount of experiences and also really interesting views about AI. I think it can be really beneficial for you to understand AI itself. Okay, so let's welcome Chunhui. Really appreciate the fact that you spend time here. And today I know it's a kind of emergency situation, so really appreciate you're spending time. Yeah.
Well, thank you, Michael, for having me. Hi, everyone. Although I can't really see all of you, but I feel like you're there, and really happy to be here. Well, it's probably an emergency for Michael, but it's definitely an opportunity for me to share my experience and to really talk to you about AI, which is something that I've been doing for the past 10 plus years.
Right.
So maybe just a little bit about myself. I met Michael at Caltech when we were both undergrad students. Actually, a fun fact is that Michael is my first and last roommate at Caltech.
That's right.
Right? If you remember it. Yeah. So we have done a lot of things memorable. But it is also the place where I first started interact with AI, especially a subdivision of AI called computer vision. Mm-hmm. So computer vision is a part of AI that let machines to see, be able to understand contents from images and the videos. Mm-hmm. So that was the first time when I was at Caltech. I did a SURF program. It's kind of like the summer research program, where I had an opportunity to be in a vision lab, working with a professor on understanding some movie analysis, understanding the video content. So that was how I get to work on vision. And then I moved to Berkeley to pursue my PhD, where I work with Professor Malik. He is well known for working on a lot of very low-level vision tasks, such as recognition, understanding, reconstruction kind of work. So I did my PhD there, primarily focusing on object detection, object recognition, object segmentation, very low-level tasks of visual understanding. And then after graduation, I started my first job at Google, where I spent actually 6 years there, working on a variety of applications of computer vision for the Google products. So I can expand that later as we goes by.
Yeah.
And then I left Google to join a startup that also focuses on computer vision tasks, but it's more about landing technologies into real application scenarios. I think there are some interesting stories there that I can share.
Yeah.
Yeah. But now I left the startup and then went back to Google, and now I'm in the Google Cloud team. Basically, I'm managing a team that is in charge of all the video and the vision applications for cloud users to use.
Right. Yeah, that's thank you so much, for walking us, through that journey. This is 14 years, something like that, 16 years.
Yeah, roughly. Yeah, 15 years. Yeah.
So, I actually want to go back, right in the beginning. When I remember, I think it's back in 2005-ish, even. We were you were taking a computer vision class, right? And I think it's in our junior year. And can you reflect that about that time? What are the things you learned, that in that class that is still kind of transferable to, sort of what you're doing now?
Definitely, yeah. So I think one of the things that, in retrospect, one of the things that I learned from the experience, especially in college, is that it's much easier for you to understand what you don't like rather than what you like. I still remember in my first year, I did a self program in a photonics lab, where I was a double E major, so I worked on, doing a fabrics optics stuff, and suddenly I realized that this is not something that I want to pursue for the rest of my life. So it's about exploring things. So I think that in my junior year, as I mentioned, I took this computer vision class. Actually, the instructor of the class was my academic advisor by the time. But I never had interest at the beginning to get into that kind of stuff until I took this class. And the first class that I learned is about how do you make a face classifier, like a face detector from the crowd image.
Right.
And this suddenly brings me some new perspective about what we can teach machine to do, right? I mean, nowadays face detection becomes so popular, you don't feel that there's no magic at all. Like it's feel like everybody can do it.
Right.
But back in that time, 2005, I think the first paper that can successfully detect faces from the crowd scenes with a reasonable accuracy was only like maybe 1 or 2 years back.
Mm-hmm.
And that was kind of the only system that was working by the time in the kind of computer vision community. And I was quite amazed by how simple the methodology is.
Mm-hmm.
That basically a face detector could work reasonably well. I tested on some of my personal photos, and it just finds all the like hidden faces from the photos magically, and that suddenly really motivated me to continue to work more on this
Right.
area. Yeah.
Right. Yeah, that's so well said. That is, like when you're young, you're not fixating on any particular direction, but to keep an open mind, and so that you'll be able to, experiment, to explore, and somehow that can lead to maybe things, areas or things that are totally unexpected, but it's going to be good for you for the long run. Yeah, I think that's really really cool. That's really cool.
Totally.
Yeah.
Yeah.
And then I also remember the stories that you told me. There's just so many stories I can relate to. It's just so easy to have this conversation. And to be honest,
Yeah.
like I wanted to have this conversation with you for a long time, right? Because it's kind of interesting to have this kind of format and we both reflect a little bit.
Right.
I remember, you talked about you went to UC Berkeley. And I remember you wrote somewhere, and you finally joined, Professor Malik's lab, and I want to actually like talk to you about like can you reflect a little bit like how did you chose that lab, and in retrospect, what do you think is the best thing you got out of that PhD research experience with Professor Malik?
I see. Yeah, it's a big topic. Let me just answer this like step by step. Okay.
Right.
Let me
Right.
first answer why I chose Berkeley and
Yeah.
maybe a Professor Malik's lab at that time. It was actually not a difficult decision. The reason is, as I said, it was easy to understand what you don't want to do, but it takes time for you to understand what you are really passionate about, and what you want to devote the rest of your career working on it.
Yep.
So by that time, I had interest in computer vision, but I still don't know. I mean, from the face detection and the movie analysis that I did in Caltech, but I still don't know that if this is something that I wanna do for the rest of my career. But it's interesting enough for me to take a step to pursue a PhD. I think that's kind of in this area.
Yep.
And there are some good vision labs by that time, but my Caltech advisor was actually Professor Malik's first student by that time. So there is this kind of like academic ancestry there. Exactly. Yeah. So there's Professor Malik's lab is definitely a big attraction to me. But by that time, I'm really motivated to go to MIT. If I don't know if you remember that story, right? MIT is kind of the school that everybody wants to go for research study, especially.
I thought you want to stay in California or something. Never mind.
Well, there are some other factors as well, yes.
Yeah.
But but I changed my mind after the open house, just because I think they made a mistake by having an open house in March, which is seems to be one of the coldest weather there. And then when I was there, I was like, oh no, this is not the place I want to go. Especially in contrast after a week when I visited Berkeley, in California, the sunshine. There's such a like huge contrast between these 2 minutes, and that just makes me it just make me want to continue to stay in California.
Right.
So well, that's part of the story. Actually, that's not joke. That's actually part of the decision-making process. Weather is quite important. But apart from that, I think Jitendra's lab, by Professor Malik's lab, interests me the most in terms of how solid his research was on. I mean, basically, if you look at the vision community, even nowadays, you can still see that there's a big bubble in this place, especially when nowadays AI becomes so popular. People want to work on different levels of the problem. Some of them are low level, really like trying to understand how machine can understand what's in the image, like what a person can do, right? Those are very fundamental tasks. And many of the people, they try to kind of dodge this question by making use of the results from these results and then making some like high-level applications. Like, let's say if I were be able to detect the people, right? How am I making use of the signals for some interesting application, like traffic sign detections, or like like some everyday life applications. So that certainly serves as a good research as well. But by that time, I'm more motivated in the science factor of the vision, which is to understand the fundamentals, how things work, why they work. And Professor Malik's lab is just, it's a no-brainer to me by that time, because it's pretty much just the best lab that I can get by the time in the world. So then the next question is, how do I learn from the experience? I think that I spent 5.5 years there, and it was really a memorable time. I think what I learned is that so Professor Malik, he gives us, he is very like an influential person. He doesn't not only just taught me, computer vision, like research papers, science, but also taught me about how you approach a problem, how you like understand the problem from the first principle, right? Like from the scientific point of view. Basically, what I learned, which I would say that I won't be able to learn from other places for computer vision topics, is that he taught us to learn from a person perspective, right? From a psychology perspective.
Interesting.
How we can mimic a machine to think like a human, right? So when we look at things. So when you design about those architectures, about this the pipelines of the detection object detection pipeline, you really can relate that to how the visual information is perceived through the visual system of your brain. Like there are like cascades of different steps, where each step perceives different levels of the visual information, and that's something that really motivated me to try to make machine to understand how an image contains, like how a person perceives that information. So a lot of insights, the design ideas come from that aspect. So I think that's if I were to pick one thing from that lab, that will be the thing.
Yeah. That's well said. I resonate, with that understanding, and I want to follow up in the sense that, I was basically looking at the list of publications you had, and it turns out like you published this paper called "Recognition Using Regions" that had a lot of citations. I was just thinking, like what was that like the central ideas, behind that paper, is also like, like basically fall in the lines of what you just said, which is basically, we can dissect our, visual system, see how it works, and then, gain some intuition and apply it to the algorithm that we can use in computer vision, and therefore we can gain more understandings. Can you talk a bit about that paper and what's the central ideas behind that?
Of course, I think this is actually a very good example of illustrating how I learned from the human vision. So recognition using regions is still an old paper. It was back in 2009, so 11 years old.
Wow.
It's a pre-deep learning era, right? So you can think about, it's not about the feature learning. It's about designing the pipeline to make use of handcrafted features for accurate detection and recognition results. So it's very different from the nowadays type of the styles of the research papers. But the idea I want to highlight here is that basically that paper is about how are we able to let machines to efficiently locate the objects of various types in the images. And there's a little bit of background there. So back to that time, this proposal generation idea is actually not actually a popular idea at all. So when I say the proposal generate idea, I mean how you basically focus your attention to a certain aspect of the image instead of scanning over the entire image to find the right object, right? So the recent ideas such as like all those anchors in the, like, for example, in the fast RCN paper, as well as those the recent attention-based mechanism, that are like all derived from that idea. But by that time, it was not obvious that this is the case. So when we talk about object detection back in 2009, what people typically think about is still like so-called a scanning window, like sliding window approach. What it means is that instead of finding directly where the object is, let's say there's a swan in an image of a lake, right? But the swan can be anywhere in the image. So what we detect the swan is that we find a window and we slide that window over the entire, a small window over that entire image. And for each window, we ask the same question: is there a swan in it? Is there a swan in it? And basically turning the detection problem into a classification problem. Binary classification problem. And then once you have some of the activations from some of the bounding boxes that says that there's likely to be a swan there, then you would imagine there will be like overlapping boxes right there. And then you apply some non-max suppressions to remove the redundancies and to get the detection result. So this is like the typical path back in 2009, how people solve object detection. But it's, as you can imagine, it's super inefficient, right? You have basically thousands of tens of thousands of windows to scan, and you don't know a priori what the size of the object is. So you have to perturb with different sizes and do the sliding again to find the right size and the right location. Yeah, it's extremely inefficient. So what we learned is that we know that humans don't do it like that, right? When we look at an image, we don't do the scanning. we somehow can magically find the object in the image. How do we do that? So basically the neuroscience ideas behind that is that we perceive the shape information from the images very quickly. We are able to perceive those shape information very quickly through some sort of like low-level edge detections. So once you have the edges, you roughly have the silhouettes of the objects. And using those objects, using those silhouettes that actually naturally conforms the so-called regions or like visual segments or like a fraction of pixels that correspond to the same object, right? So you can really go from the bottom up instead of the top down. Right. So that's how that's what the inside of the paper is. So we start from the bottom up idea. We detect the edges. We form the regions. And then we build recognition algorithm on top of those regions.
Got it.
And to automatically decode the location as well as the size of the object from the images. And also the shape as well.
Yeah. So sorry to interrupt, but
not only gives you not only gives you classification result, but also the detection result, knowing where it is, and also even the segmentation result, which pixel belongs to the object.
Yes.
So everything becomes just one thing, from this bottom-up approach. So that's kind of the beauty of the paper.
And I think it's really beautiful, right? Because this is actually, prior deep learning was, taking over the computer vision kind of research. And when you look at, for example, like how our brain, organizes itself, just from these simple early experiment by Herbert and Weasel, like when they experiment with cats, brain, they were finding neurons that are responsible for detecting edges, right? And somehow these edges, they have to come together to form higher level feature set, and maybe those higher level feature set can then enable you to do classification. That's really amazing. And it sounds like that's almost like like we have this, like now we have this understanding, but certainly at the time when you try to explore this and using especially like a method that's not very popular yet, that's really impressive. Thank you for walking us through that journey.
And also I want to just use this opportunity to highlight one thing, which is really believing what you do, right? I mean, if you were thinking about the popular trend, you won't be able to really break the trend and do something that you believe that is right. Sometimes, like, popular trend is not necessarily the ultimate right thing to do, right? So, but it requires some of the courage to break in and to really try something that you believe would work in the long term.
Yeah.
I think the neural network is actually one of the perfect example for that as well.
Yep.
It has been idle for almost 20 years. No one believed that it will work.
Right.
But if you now look at it, you would really admire those, the people who developed and created the neural network, and and keep it up until like for almost 20 years to get the popularity here.
Yeah. So I want to ask you, something related to this. Like when you said don't give up, and one of the things that I think you dealt with, whether it's like doing your research area or working at different companies, and we all do, which is like I wonder how you deal with failures, right? Because when you try to explore new things, like most of the time we will fail. How do you sort of like view these failures? How do you manage your own psychology so that you would believe yourself and go for it? Could you talk a bit about that?
Sure. Yeah. I think my perception to failure is just embrace it. Embrace the failure, because success. I mean, this is something that everybody knows by saying, but you need to put that into practice. So the success comes out of the failures. Basically, let's put it this way: if you want to invent new things, typically nothing. I mean, if you I guess nowadays, because computer vision becomes so popular, even maybe high school students have the opportunity to play with the models, right? I guess
that's what we do.
And to run that's what they do probably, like, and running some experiments. Yeah. But the thing is that what you are doing is that you are building on things that people already proved to be working, right?
Right.
So it's more like doing a homework where you already have the answer.
Right.
But I can tell you that in the computer vision community, basically, I most of the time it's not like that. We are joking one day that actually we should have a conference that collect all the failed ideas instead of the successful idea, because if your idea fails, you cannot publish a paper to conference.
Right.
So the conference only collects all those successful ideas, but actually what you learn most about what works and what doesn't work come from all the failures.
That's true.
So just embrace it. I think embracing failures is very important. I cannot imagine how many failed attempts that I had in my journey.
Right.
But it was not until these failures that makes me to be what I am right nowadays, because I learned a lot from that.
Yeah. Awesome. Well said. So I also wanted to, I think, one of the most interesting experiences you had was, you first came to Google, you work at, Google Maps team. I remember I would visit, with you, you took me around the buildings, and then, like later on you transitioned to work for AIB, which is more like using AI to like help, other, maybe like business to succeed. And now you're going back to Google. And can you talk a bit of, maybe first, just a very simple question, what is it like to work at Google? What's the sort of like daily things you would do, when you first joined?
Yeah, sure. Yeah, I mean, Google is very big. I think nowadays there are like 100,000 people. By the time I joined, there are like about 50,000 people. So it's big. There are a lot of PAs in Google. So the PA that I joined is the Geo. So everybody hopefully likes Google Maps. I like Google Maps by the time. And also, I really want to contribute to Google Maps. So one of the features of Google Maps is about street views, right? Street view images. So this is something that people use mostly to explore the kind of neighboring environment are. But there are actually a lot of things that we can do out of it. I think Time Machine is one of them. So you use this street view images to really know at a particular location what it looked like 10 years back, 5 years back, 3 years back, and things like that. So there are a lot of applications you can build on top. So the team that I was in was to use those street view images to pull out the information, content, semantics from those street view images that we can use to add into the map database and to enable the users to have a better user experience.
Yep.
So for example, you look at the map, you see there are a lot of like street names, right? Yeah, like each street has a name on it.
Right.
But you don't get those street names by free. First of all, you have to typically not all countries have those third-party providers that you can purchase, and also those information are not necessarily the most latest, right? They can be out of date. They can be updated at any time. So how do you get the refresh data from that? So Street View is one of the resources that actually we get. So when I was there, one of the projects I worked on is to find all the street name signs from the Street View images and transcribe those signs and put those names back into the Google database.
How many languages?
So that's kind of the hidden magic. Oh, I mean, we work on like, I think let's say 50 to 60 countries where we have the Street View cars driving, right? And we pretty much do everything there. And you can imagine, like, it's actually good. It's an interesting project if you are interested in knowing what the signs in other countries look like. Yeah. So the signs can be very, very different colors. Even in the same city, there can be different types. So it's actually a challenging problem, but it's also a fun problem to work on. Yeah. And also you can extract not only signs, but also like, let's say traffic signs, right? Traffic signs gives you all those traffic information, knowing how many stop signs at intersections, and also the local, like the storefront, right? If you want to search for a local business, how does Google Maps know immediately where this local business is at a certain location? Right. I mean, we can scan from the local businesses and scan the names and all those like related information that the storefront has on the street. So this is kind of magic, but this is actually what we are doing at Google to provide the most state-of-the-art methodologies and to provide the refresh data for users to use. Otherwise, like for local businesses, 20% of the local business change every year. So how do you keep track of those changes? You won't be able to get the data directly typically from the content provider. You really have to do some active scannings of the streets and to get those data.
Yeah. And this is wonderful. And one of the things I actually like talk to our students about, which is like, when they were working on their, like student product, one of the things I actually tell them to focus on the life cycle of the data, because garbage in, garbage out, garbage in, garbage out. And I wonder, like, from your perspective, like you graduate from UC Berkeley, that's in academia settings, and then you come to Google, that's like, not only you have to get the algorithm working, but also it's like you have to deploy it to a scale that's like billions of visits and billions of people. Can you talk about the engineering challenges, specifically related to, deploy your product?
Yeah. I can talk about two engineering challenges. The first engineering challenge is how do we deal with the large scale of data, right? And the way to deal with large scale data is to make sure that your system is scalable. I mean, it's kind of like a nonsense, but this is the fact. So being scalable means that you cannot apply very computationally heavy models for dealing with the data. So basically, there's a big difference between academia and the industry in terms of applying computer vision researchers. So in academia, the most of the focus, if you look at the papers, was on the accuracy or the quality of the models. Basically, if you're working on a 3D reconstruction, you look at how well the constructed data is from your output. If you look at even if that algorithm can run like for days to generate only a 10 square feet of the area, right? People don't care. They care way less. But such system cannot be deployed in industry because of the speed requirement. Nowadays, I'm working in Google Cloud. We are processing like petabytes of videos from the users.
Yep.
And one of the key requirements for our models is that we need to make sure that during the inference time, we are able to run our algorithm process a video no longer than the total length of the video itself. So for example, if you know we have well, why is that surprising about petabytes? If you look at the if you look about the YouTube, it's even bigger.
Yeah. No, I'm
Yeah.
just surprised.
That's the kind of that's the kind of scale that, no, I was joking. I mean,
The inference time.
that was the kind of scale that we're working on. Yeah. Anyway, so if we are processing a 10-minute video, we want the whole analytics processing time to be less than 10 minutes. So that's kind of a hard requirement. So we have a speed requirement. We also have a computational resource requirement, right? We don't want to run one video with like 4 GPUs or like 16 GPUs. That's just a waste of resource. So we need to optimize our model, both not only for the accuracy, for the quality, but also for the running time and also for the computation resource consumption and for deployment efficiency as well. A lot of other considerations. So this is one. The second thing I want to talk about the processing user data at the industry is that we have to be very careful about the privacy, right? Because in academia, a lot of data are licensed to be freely used in research for research purpose, but that's not the case for commercial. Users upload a lot of data. They bring a lot of trust to us to keep the privacy of their data. So we need to be very transparent about what we are capable of doing and what we are not. Just to give one example, for some of the live analytics experiments on some products, we need to make sure that we have all the faces and license plates blurred, right? As a first step to before analyzing those images and the videos. So this is something that particularly we need to be very careful and be very serious about to make sure that we don't take advantage of we don't invade users' privacy and give them really we get them trust to use our product.
Yeah, that make a lot of sense. I'm still very curious about like basically like when you think about your lives at UC Berkeley and then work at Google, one is a lot small scale, the other one is a lot bigger scale. It sounds like you probably learned a lot of engineering skills at Google. Can you talk a bit about how did you learn about that? One of the things that I'm trying to get students to think, to reflect a little bit is learning never stops, and I really wonder for you to scale yourself from very little engineering to go all the way at a Google scale. How did you sort of achieve that? What's the time kind of scale that for you to do it?
Yeah, I mean, I can talk a lot on that topic because it's truly a big difference from a research lab to a company like Google. And although I haven't been to some other big companies in the US, but by talking to my friends working in the other companies, I feel Google is really a great company for you to grow. The company really cares about your growth. Sometimes gives you the trade-off between productivity versus growth. So it allows you to spend some time learning things, using your 20% to learn things at Google, temporarily forgetting about what you actually do for your main business. So that's really that flexibility is really nice. So what I learned from working at Google is that basically so there's a huge difference between research output and the industry output. The research output is pretty much just a paper, right? Like you prototype some models, you run against some state of art, you get some state of the art numbers from some benchmarks that everybody likes, and then you publish a paper, and then you're done. You move on to work on something else. At Google, getting that level of the output is just 10% of the journey. There's 90% of the journey about optimization, scalability, and automation about the pipelines, right? Because eventually, and quality control, eventually you are building a product, right? You have to understand, if I do this adversarial testing, how likely this is going to break, right? You have to do a lot of things like that.
Right.
So there are several stages of testing, including the initial unit test, regression test, and then there's a stage where you think that this product can be internally released, but then you have all the internal users to test. We call it dog fooding. It's like you dog food your product before you release to the public. So there are several steps of testing. I think this part is very, very rigorous, and that's something that you won't be able to learn until you joining a company of that size. Yeah, you probably don't even learn that from a startup environment because you don't really have the luxury to get several cycles of the product.
Yep.
Yeah, that's a big thing. And another thing that I learned a lot from industry is that getting yourself, so getting yourself, getting stuff assigned to getting stuff done that is assigned to you is just only a very small part of your daily operation. Because you need to communicate a lot, with your team members. When you are when I was an individual contributor, I have to sell my ideas, right? I have to reach out to my downstream teams about how to make use of these our street sign outputs for their map user experience, so to enhance their map user experience. So these kind of communication across teams, within teams, are essential for you to be able to justify the impact of your work. And that's something that you learn a little bit from school, but that's not as important because the main way that you interact with the community is through papers. People read papers. But in industry, if you just write design docs, that's not enough. You need to communicate verbally and also through some presentations to other people for other people to understand your work.
Build that.
So that's very, very critical. Yeah. And nowadays I'm managing a team that becomes even more and more important, right? I need to know what they are doing, what kind of obstacle they have made, and how am I able to help them to resolve the obstacles.
Yeah, I can just imagine your as you grow, the communication piece probably take more and more weight in the daily time that you spend. Yeah.
That's totally correct.
Yeah. Okay, so we have another maybe 4 to 5 minutes, and I wanted to ask you this question, which is you have been working in computer vision for quite some time, all the way from the beginning when it's not even popular, and right now it's like, wow, it looks like object detection is some solved problems already, for neural nets. But I wonder, from your perspective, in your opinion, what are the large scale applications for computer vision? Can you talk a bit about that future?
Yeah. Right. Yeah. I think there are a lot of opportunities ahead of us. When you look at the industrial revolutions, right? I think we are really at the edge of let's say, the so-called fourth industrial revolutions, where people use the information as a way to perceive and act on a daily basis, like streaming information. So I think it's really a big part of the future. I feel it's already actually coming. So the way to digitize the world, in my opinion, is actually the next wave of revolution, right? I mean, it's not some new concept, I think, but I truly believe in that because I have seen a lot of evidences. It can penetrate, the AI can really penetrate a lot of traditional verticals, business verticals, changing things how they normally operate, improving their efficiencies, or even creating new opportunities that they currently could not create out of the traditional way of doing things. Let me give some examples. Let's say one of the examples that we are currently working on is that is basically we are trying. I mean, now it's a COVID time, right? COVID time is very difficult for a lot of businesses, but it also creates some opportunities. So one of the things that we are working with one of the entertainment company. Everybody knows that company. It's called Disney, right? We work with Disney. And what does Disney want? Disney wants to reopen their parks, right? But one problem is how do we make sure that they can reopen the parks safely? right? How can they do that? There are a lot of things that they can do, but one of the things that they have in mind is that how can we kind of like automate the process of knowing whether there is a security, sorry, a social distancing violation at some locations, right? And then they can make some like basically interventions to avoid that from happening. So, well, there are sources of doing that. You know, there are like security cameras in the public areas of the park, right? And those security cameras have a lot of footages, but it is infeasible for human to look at all those footages and to make real-time responses to any of those social distancing violations.
For sure.
But actually, we can do that through computer vision, right? All we need to do is we just build some streaming functionality plus some AI analytics and deploy them on their local environment. And we build person detector, like, you know, starting from the basics that everybody here probably knows, from person detection, tracking. And once you have the tracking data, it really allows you to do a lot of things on top of it. And it allows you to know at a certain time where this person is in the park, right? And if you know the location of the person, every person in the park, then you can easily compute the distances between those people, right? And that gives you the information about those the tracings or like monitorings of the social distancing violations. And yeah, so okay, that's interesting. So the idea is not difficult, but if you think about the usability, that's just like amazing, right? I mean, how many business benefit from that and make the environment more like a safe place.
For
And also, you know, for retail, right? I think the traditional retail. When I say the traditional retail, I mean the offline retail has been pushed a lot from the online retailing channels. Like most of people, youngsters, like buy things on Amazon's right now, but the offline retail still has their values about things, certain things that you can those kind of like experience that you cannot get from the online retail. But how can we kind of renovate the offline retail business through AI? So one thing you can imagine is that actually this offline traffic gives you a lot of opportunity for the business owners to understand what kind of improvement they need to make to improve their business, right? Like whether they are doing a good job attracting the customers. When you see actually in a mall, there's a lot of people passing by, but very few people entering the mall and entering the store. Right? Then there could be an indication that the store might need to do some more like behind the window ads to really attract people to enter, so things like that. So knowing these offline traffics can really help a lot of business decisions for the owners and to optimize their operations and daily operation flow. I'm just making some very simple examples. A big part of it is security. Right? People want to live in a secure place, and the security is a big part of it. To do it in an automated way, because we have just so many like streams, and with the emergence of the 5G, this becomes more like more tractable. The solution becomes more tractable even for machine to really scan over the videos and to detect the abnormalities and to understand where things go wrong and to quickly just send the alert or any feedbacks for any of the post processing or postmoderns on top of that. So this becomes a huge market that you cannot imagine 10 years ago.
Oh yeah, for sure. Hey, right now it's 12:47. I wanted to maybe just open questions for our students here, and to see like what kind of like questions they may have. But while they're everyone if you have a question please ask. Why don't you you can just type into the chat, okay? And but like Chunhui, like this is really a wonderful time we spent together. So appreciate you walk through, your journey with us. It's really awesome to see that, you were doing the research that are not popular at the time. Somehow, like, right now it's the mainstream, like how we do computer vision. thanks for like also talking to us like, like your learning experience, what is like scaling up the, engineering or, growth in your career, and how do you deal with failure and how do you learn. These are, tremendous insight. I'm so grateful that, like today's also emergency kind of situation. I'm so grateful for you spend time here. So
No,
guys,
it's a great pleasure for me to be here and share with people. Yeah.
thank you. Anyone have questions? Do you have questions? If you have a question, send in the chat. Okay. Yeah, actually, you can also ask. Okay, just unmute and you can ask. Okay. So let's give people a little bit of time. We also realize like today is a not good day for a lot of students because it's in the middle of the week, 12 p.m. I think next time when we give like invite speakers, we should do it during the weekend. Maybe it's like that time, people have more time, to participate. Yeah. Anyone has questions? What kind of questions you might have?
Yeah, happy to talk more, even offline, with students.
Right.
And okay, yeah. There's one question, but just to complete, feel free to share my email address, and I'll be happy to answer any questions.
Yeah. So there's this question here.
Okay.
Have you also
go ahead one by one.
Yeah, with other companies before? Okay.
Yeah. So nowadays I'm in cloud, right? So one of the big vertical is to how do we sell our AI solutions and help other companies to with their own businesses.
Right.
So we worked a lot with other companies. Disney is the one that I mentioned, but there are at least like 10 or 20 companies that we have closely collaborated with. Most of them are actually the big head companies in different verticals. And those are the ones that really are willing to try to embrace the AI technologies and to revolutionize their business. Can computers make mistakes? Computers make mistakes all the time, right? It's not about so if you talk about the accuracies, I don't think there's any object detector that can give you 100% accuracy.
Yeah.
I'm not sure if this is the right way to interpret this question. But they don't make mistakes in terms of logics, but they make mistakes in terms of meeting the perception standard of what a human can do. But there are also areas that the machines can do even better than humans. One example is this fine grain classification, right? If you want to, classify different species of birds, right? Unless you are like a bird expert, you probably cannot do as well as a machine, like a best bird classifier algorithm can do. Yeah. How popular in academia is the notion of approaches tasks from the point of view of psychology, as you said in the beginning? It's unfortunately not that popular because one PhD is actually busy enough for most of people in computer science. So few of them actually really either have a lot of exposure to neuroscience or psychology, as I mentioned earlier. But it is really this interdisciplinary kind of research that can help you to really open up your mind to make innovative work rather than making incremental stuff on top of what other people have been doing. Yeah, I think that's very important. But unfortunately, this is not the norm, basically. Yeah. What would you recommend as a field to study together with AI? So, well, from the high school perspective, I think math is quite important. I think, and coding, math and coding would be the fundamental tools for you to be able to master AI technologies and to be able to make, useful, to build models on top of it. But in terms of a field, particularly, I would say, I think neuroscience. You're talking about AI, right? AI is a broad topic. it includes natural language processing, computer vision, speech recognition, and so on and so forth. And each subfield, I think, has a related field that could be coupling together to really help each other. I can only speak for computer vision, and for computer vision, I think neuroscience is very important. As you described AI earlier in terms of replicating the way we think into machines, do you believe that cognitive science with a specialization is a growing field? Because right now it's considered more research than application. Yeah, it is. Right. There are probably some examples about how a research field can be turned into a more like application field as time goes by, but we just need some breakthrough technologies. I think deep learning is actually one of them. Deep learning really make people to start to get aware of the neuroscience kind of technologies. Yep. Because that's how a neural network is mimicking the neurons in the brain, even though actually functional wise they are very different. So, but I think it takes time, and it really requires some of the breakthroughs in both fields to be able to benefit from each other in the application field, and that takes time and takes maybe one day self-driving car can benefit a lot from the neuroscience way of thinking about interpreting the pedestrians movements, right? If that becomes the case, then people will get a more round of interest in learning neuroscience. Yeah. What steps do you recommend we take in learning computer vision? Math and coding is your weapon. And then starting from something simple, right? Some code labs and some, small projects. Now, right now, you guys are very lucky because there's the GitHub that you can really, pull out the off-the-shelf algorithms and then just test it on your mobile phone or things like that. And I think curiosity is very important. It allows you to, it drives you to dive into the technology, to really to learn by yourself, to understand what's kind of the what's behind the magic, and that's always a good way to approach AI. I don't think reading books is a good way. Yeah.
So I want to actually make sure that you have time, to eat, to go to the bathroom, to drink, before your 1 p.m. You got 5 minutes, So I want to actually to say, like, I really appreciate your journey, your wisdom here. Like, I personally, as I said, I really want to do this, for a long time. Today, I finally got the chance, and it was a big favor that you gave, to us, right? Like, substitute for this one. So I really, really appreciate it. Let's follow up later. And, as I said, I really appreciate it. And everyone, can we please give Chunhui a round of applause? Thank you for his time, for his journey, for his sharing, for his honesty, right? So really, really appreciate your time here. Yeah. So with that,
thank you. It's my pleasure. Yeah.
So with that,
thank you for having the opportunity. Yeah.
Yeah. So with that, I just want to close it. Everyone, you got questions and stuff like that, send it to me, and I will relay that, to Chunhui. Okay. Yeah.
Cool. All right.
Thanks, everyone.
Thank you.
Yeah. All right.
Yeah.
Bye for now. Yeah.
Bye.
Bye.